Right, I'm going to go ahead and start talking through this. Okay. As always, we're going to begin by just copying down our givens in the exact form that they appear. So don't interpret it. So they tell you that GI bisects angle FGH. That tells you some more specific information, but don't interpret it in this step. We'll interpret it in a separate step. So I can label FG and GH. Okay, and if I know that GI is going to bisect this angle FGH, what do I know about the two angles that make up that larger angle? They're going to be what? Equal. Okay, so I know that these two angles right in here are going to be equal to each other, so I do have to state that. So I can make the statement that the measure of angle FGI is equal to the measure of angle HGI. Okay, and that's based on what? Definition of bisector. Good. It tells me that they bisect, so based on that definition, I can make the statement that those angles then must be equal to each other. Okay, so now if you're looking at the congruence of these triangles, okay, there's two different ways that we can approach this. Okay, we can go one of two ways, probably based on the fact that we just looked at SAS. Okay, if I wanted to use the SAS pattern, what would my next step be? Between these two triangles, I have a side, an angle. What's the other side for which that angle would be included? GI. So I could say that GI is equal to itself. Again, going back to reflexive property. And so now I have two sides, the included angle. Is that enough to show congruence of triangles? Yeah. So in step 4 here, I could now make my statement that FGI is congruent to HGI. And the pattern that's fulfilled here is two sides and the included angle, so SAS. Right. Did anybody do it a different way? Yeah.
I didn't do number 2. I just thought my number 2 was GI.
And then you just, so you, like, and then you did it in 3 steps?
Yeah.
Okay, so you do, specifically, you can't just use the interpretation of this rule. You actually have to physically put that into one of the patterns, or one of the statements. All right, let's go back before we did step 3. Okay, what do we know about this triangle if I just looked at this? We saw that FG and GH were equal. Okay, what do we know about this triangle? Brennan? Yeah, so you have an isosceles triangle, right? FGH is isosceles. So you know that the base angles F and H could be equal. So instead of this step 3, we could have had a separate step 3. Okay, so let's say we wanted to look at it without this pattern. We could have said in step 3 that angle F is equal to the measure of angle H. Okay, and we've talked about a property. This is one of the definitions and properties that we looked at. And so you could simply say, in this case, angles opposite equal sides are equal. And that's what the specific relationship was, right? Base angles of an isosceles triangle are equal. It's more generally interpreted, angles opposite equal sides are equal. So we could have made that statement, that we have these two angles now. So again, we would be disregarding GI for right now. So we have two pair of angles and the included side. Is that one of our patterns? Yeah, so we could have justified this as step 4, 2 angles and the included side ASA. Okay, so either of those would have been fine.